Okay, welcome back to second semester. So we start with dynamic. So your class got two slots. One is every Monday, 2 to 3, then Tuesday, 11 to 1. So total you have to be 3 hours. And then this semester, all of you are taking the engineering lab. Basically, engineering lab, you cover 3 modules: static, dynamic, and solid mechanics 1. Okay. Okay. So basically, this module is a continuity of static module, but it's a little bit more fun because you are seeing object moving. Rather than static, the object is not moving. Okay. Just to summarize the whole chapter, the whole module, chapter 1 until the last chapter, basically we are studying only one equation, and then we expand it, which is F equal to ma. Okay, F equal to ma. So, but from there we expand into momentum, energy, and so on. Okay, right. So for this module, what you need to mathematics side, you need integration. You have to be very good in integration and differentiation. For this one, so if you are weak in these two mathematics skill, please go and polish up, because it's very, very important. Almost every question you need differentiation and integration. Okay, so these are the 4 learning outcomes with CLO 1, 2, 3, 4. So first we will learn object moving in straight line, and then we will learn in curvature line, means it will in a curve. So these are 2 motion in dynamic. One is straight line and then curvature. Then you need to apply Newton's second law with this F equal to ma to solve the issue, to solve the problem, right? So basically you are dealing with force and acceleration. So you have to link force and acceleration. Mass usually doesn't change. Mass doesn't change in this module, but you need to consider some factor in the later chapter where there's a reduction or reduction of mass, especially related to rocket question. Okay, because you burn some propellant. Okay, and then you have to bring back what you learned in static, where all the physics parameter that can link to acceleration, distance, velocity, then to acceleration. So it can be differentiation from distance to acceleration, and you integrate again, it become acceleration become distance. So 4 parameter important for this module. Force, mass doesn't change, usually will be given. Or sometimes all the parameter will be given, you need to find what is the mass, initial mass, right? F, M, A, right? And then from A, you need to find distance, velocity, and time. So basically these 6 parameter: F, M, A, V, S, and T. So these 6 parameter, you will play around these 6 parameter throughout this module. Okay. What else? Okay. Now then you need to cover rigid body and planar kinetics. Rigid body means the body mass doesn't change. Rigid, very rigid, right? It doesn't change shape. So when the object doesn't change shape, the mass constant. Okay, and also because rigid body, you need to find CG in the later chapter. So you need to bring back what you learned in your static. Where is the center of gravity? CG, right? Planar kinetics means it can be 2D or 3D. When it becomes 2D, it just moves along the paper. This is a planar 2D. Okay, you assume the object moving in the planar or 3D. 3D means you're X, Y, Z. Okay. Now throughout this module, you have 2 terms to describe the object. In the beginning, you will use dot, you assume as a single body. Chapter 1, 2, 3, I think so. You assume the object as one body. 4, 5, 6, 7, and the last chapter, you assume is a rigid body where it consists of many parts. Okay? Now, mean that in the beginning of chapter 1, 2, 3, or maybe chapter 4, the CG is always in the center. But when you go into rigid body later, if there are 4 parts, you need to find 4 parts CG. Then you combine the effect. Okay? That is what you will be experiencing throughout the semester. Right. So, okay, assessment will be 60 and 40, meaning coursework will be 60%, final will be 40%, right? Passing mark will be more than 40 marks out of total. But this is what I assume you will do lah. You will score more than 50%. Okay. What I will do is we will have 2 tests. Each test will be 20%. Test 1 will be around week 7. Now it's week 2. Right? Test 2 will be around week 13. So if we can cover earlier, then week 12. Right? And every test, after the test, if most of the class is not doing well, then I might give you a retest with option, but that one need to see how you score in test 1 first. Same like test 2. Individual assignment, this one, like what you've seen in the previous module. The assignment question will form tutorial question that I give you. I just pick and then you answer and you submit the answer. Okay, so basically 20% is a sure point, means if you submit and you give me the correct answer, you get full marks. All right, now some of you might not get full mark because some of the slide I do not derive the equation, but in the assignment you need to derive the equation. So let's say the question is 10 marks. On my slides, I skip the derivation, I skip away, go to the more major steps. But if you copy exactly the slides, you might not get full marks, 10 marks. So for assignment, you need to do a bit more expansion of equation and so on. Right? Now let report this one refer to mechanical lab 1. Right? So the marks won't be 4 in here. Right? Final exam will be 4 questions. It will be linked all the chapter together, right? So 4 questions, no choice. One question about 25 marks, right? So basically, will be section A, B, and C. Section A will be normally linked with the equation or free body diagram. You need to recall back what is free body diagram. Okay. Then the first question, A section usually asks you to draw something, usually free body diagram. You need to show me the force, you need to show me the motion. These are the 2 lah. Okay, motion, force means you need to show me all the forces, including the weight. Mass, you need to change all the mass M into weight in this chapter, in this module. Okay, so there are only 2 forces, external force. Internal force will be the gravity, means the mass gravitation pull will become W. Okay, the force component. Then from the free body diagram, you need to know where does the object move, because dynamic, we deal with the motion of the object. So you need to know what is the direction of the object. Okay, now we start with 2D first. 2D will be X and Y. Every time the object moves to the right hand side or to the X component positive, we'll use positive. If the object moves to another direction, we'll use negative sign. Go up also same. Y positive go up and negative go down. Okay, and Z will be always positive pointing out of the paper, this direction. Okay, and most of the time we will use right hand rules. Right hand rules, means every time you open the 3-axis object, you use like this, and then your finger curve will be more on the moment thing. turning, and so on. Right? So your right hand is important. Okay. Okay. Then these are the chapter. We'll go very fast. Okay. So our objective today is to recall back how to get acceleration from distance, right? So if you take distance divided by time, you get what? Distance divided by time, what you get? Speed. Okay. Now, in dynamic or even in statics, if you mention speed, speed is just a constant, it is not a vector. So in this chapter, be careful, the question asks you, if it asks you speed, it asks you the magnitude of that velocity. Means 10 meter per second, that one. If the question asks you to answer velocity, find the velocity of object A. It means beside you find the magnitude, let's say 10 meter per second, you need to continue your answer with telling me where is the direction. You need to draw arrow, left, up, down, something. Okay, if 2D, then only X and Y or I and J. You learn in your engineering maths, right? X to the X direction is I, going up is J, right? So if it's in 3D, means you have I, J, and K. Okay. So that is our objective today, which is we derive the equation. Yeah, degree in this case, we work with two. One is degree, 0 until 360. And also, when we work with things that rotate, we'll use radian. Yeah. So if the object is like do not move, but it's just changing orientation, we will use degree. But if the object is twisting or there's a whole body movement, we'll use radian. So that one in later on. Okay. Okay. So first we start with the term first. The term is important. So if the word mechanics, or sometimes you see mechatronics or mechanics is focused on the state of that object. State meaning either it's moving or not moving. The state. Either it's continuing to move or it is do not move. If it do not move, mean we use the word static. Do not move, right? So mechanic, we have two. One is static, one is dynamic. It means the state of rest or motion. So static, we deal with things that do not move, right? So, but however, when all of you have passed the static already, so now we go into dynamic. We see things moving. We see things moving. We quantify by time, right? 1 second, first second, where does it go? Second, where does it go? Right? Okay. So these are all the elaboration. So during static, what you do, you always deal with all the force equals 0, which is equilibrium. All the moment equals 0, which is equilibrium. And you always have a constant velocity in statics. Means you always deal with one single value of velocity. Again, velocity is a vector form. It's a vector name. So velocity, it means consists of speed and direction. When you mention speed, it means it's just a magnitude. Velocity means there is a direction. Dynamic, also we deal with all the force equals 0, all the moment equals 0. However, there is a change of velocity that gives you acceleration. Okay, you take V divided by T, you get A. You get acceleration. So this concept, you have to be very clear first. So every time as you go into senior years, we have to know my object is stationary or moving. So you have to be very clear. I'm solving static problem or I'm solving dynamic problem. Okay, now what kind of case you fall into static problems? Dynamic problem can be go into statics. When you see the question, it asks you instantaneous situation. When you see the word instantaneous, mean you pause the time. You like taking movie and then you pause the time, it becomes static problems. Okay, right. Okay, now dynamic, you have another two more words. Dynamic means things moving. So in the question, you will see kinematics and kinetic. So don't confuse with these two verbs or two terms. So kinematics, we only look at geometric aspect. Geometric aspect means the shape. The shape. Round shape, triangular shape. Okay, triangular and so on. Kinetics, we deal with force. If the question asks you, please apply kinematics analysis. It means you only look at geometric aspect that deal with the motion. Okay, it means volume, mass, all these things mean the shape, right? But if the question asks you apply kinetics formula or analyze the kinetics dimension or kinetics problems or challenge of that situation, means it asks you to solve force problems. Okay, usually these two come together. It means kinematics, usually your question section A, you need to draw free body diagram. It is kinematic problem analysis. And then section B and C is deal with force, where you do kinetic analysis. Yeah, so you have to be clear first on all the terms before we go into more complex. But still, basically, this chapter or this module deal with F equal to ma. Okay. Okay, so these are the steps we will go through as we go into tutorial question later. So basically, when you solve dynamic question, you have to know this question belongs to which chapter. Each chapter have its own formula. If I give you hints like, okay, test one, I'll test you on chapter one, means I only use chapter one equation. I don't jump into later equation. So each chapter have its own equation. So first, you have to know what problem you are solving or what chapter is belong, right? Second, you start with free body diagram. You always need to draw diagram in this module. Okay. For the earlier chapter 1, 2, 3, you assume as one whole object means you see as a big bubble or big dot with the center of gravity at the center. Okay, but later you go into rigid body, then you break the object into component. And then you need to know your coordinate system. So this is a bit habit. You need to build a good habit. When you solve question, always know where is your X, where is your Y, where is your Z. Okay, where's your reference point? Where's the starting point? You have to know this one. So first, what chapter question this one belongs. Second, you need to draw the object, convert the problem into diagram, into box, into triangular, into so on, into shape and forces and motion. The third step is to know where is your positive direction. Go to the right, positive, go up, positive. Come out from the paper, positive. You have to know. So this one got marks one. Diagram and the axis always have 3 marks one. So throughout this module, we assume to the right is positive, going up positive. So as long as in your diagram you draw Y with the arrow point up, X to the right with the arrow, and you label as X, and Y, you get 1 mark. Even though you don't know how to solve, you just draw something and then put in the the coordinate, you get marks. Then you solve the equation. So this one, in this module, you need to solve simultaneous equation. Right? Usually only maximum 3 equations because you deal with X, Y, and Z. Simultaneous equation, you have to know. So if you are weak in simultaneous, you need to polish up, right? And also integration and differentiation. Okay, you solve, and then you need to tell me. Section C, you need to tell me if you get a 10, what does it mean? If you get a positive value, 10 meters per second, and it's a vector velocity. You need to tell me whether it's go to the right, go up, go down, and so on. Okay. Okay, then the rest you just check out whether it's logic or not. Okay. For example, how you know it's logic and not logic? If your answer, let's say you find velocity, you know that you are throwing the ball to the right. Velocity will always positive to the right. And then you calculate the final velocity negative. Means something wrong. Because on Earth, if you throw something to the right, it will continue to the right. Unless it's bound back. But our case, we random don't solve bound back question. We solve trajectory question. Okay, curvature motion. Yeah, so these are the general ideas. So we go and recap what you learned in your physics. We start with the rectilinear kinematics continuous motion. We start with the straight line motion. Straight line motion. Let's say we have a dot. And because it's rectilinear motion, so we move in a straight line. In this case, this dot moves from the left to right. Okay. Now, for dynamic, you always need to label where is your origin. You always start with O or something that you're familiar, right? In this case, we just use O as origin. Or you can put 1, you can put something else but please use O as your origin. Okay. So we need to know these 3 parameters: position, mean x, y, z. Velocity means you take the distance divided by time. How you know distance? Point to point, you take last position minus the original position. Not the origin minus the last. We always take the latest latest position or compare to the previous one. Okay. Velocity means we focus on the direction. Magnitude with direction. Speed with direction. Acceleration also. Acceleration is a vector form. Acceleration with the magnitude and direction. Like for example, gravity always pointing down. Always pointing down. So throughout this module, chapter 1, the last chapter, when you draw free body diagram, always your gravity, let's say this is the object, no matter how you twist the object, always put your W straight line down. I've seen students, suddenly gravity can be any direction one. Because maybe the student panic in the exam, but always have your gravity pointing down. Use your ruler, just draw pointing down, right? Always go down. No matter the direction, no matter the direct orientation of the object, gravitational force always pointing down. Okay, we start with the very fundamental parameter, which is distance. In this case, we use S as a distance or displacement, right? So S is a distance. So position is a vector. Since have magnitude and direction. This is a dynamic chapter. So dynamic is deal with motion. Motion, you have to move somewhere else. Okay. So position is a vector. So we start with the name of displacement. Displacement is a change of position. So original displacement will be S. Second displacement or second position, we start to label S, comma. And third position will be S, comma, comma, and so on. Okay. You can label as S0 for the origin, or S1 as the second position or the position after the starting motion, right? And so on. It can be, right, according to your diagram. But we start with a very simple notation first. So displacement is you take S comma minus S. And the S is measured from origin. Measured from origin. In this case, rectilinear is a straight line. Later, we'll go into curvature one. Then that one will be more confusing, but we'll start with the rectilinear first. Okay, first equation for today. Finding displacement, which is second position minus the original position. Okay, since it's a vector quality, you need to know the direction. In this case, the parameter, the yellow particles move from the left to the right. It means your direction is positive to the right. So in your diagram, remember to tell me where is your positive. Just put a bracket positive and so on. We're only interested in positive value. So you don't need to write negative. Is already know where is negative already. Okay. So we start with velocity. Velocity in chapter 1, 2, 3. You are using average velocity. Okay. Now average velocity means you take the delta S divided by delta T, mean change of time. Okay. Now here we use a V and sub average AVG to calculate the average velocity. Another word which is you'll see in your test one. If the question asks you to find instantaneous velocity, you need to use limit, that what you learn in your calculus or something, right? So you write V equal to limit T delta T close to 0. Instantaneous means you freeze the time frame and the object stop there. Right? So the change of time is very, very small, that near to 0, because you pause the time. So you can change, when you change the limb, you use the limb, you can change the triangular delta become D. Okay, so when you have triangular means you very difficult to measure, but if you have a limit to it, you can have measurement, means you use the different of something, D something. And you see this one is a differentiation. It's a differentiation. If you have S equation, you can differentiate with time or dy dx. If your y is S, your x is time, then dy dx will become ds dt. Basically, we're still at the physics chapter, right? Okay, second equation, which is v equal to ds dt. First one is displacement. Second one is velocity, where you take the instantaneous velocity. Okay, now for this module, we seldom deal with average velocity. We seldom deal with average velocity. We always use ds dt or d something divided by t. Okay, yeah. But as we move on, we doesn't mention instantaneous. Means if you ask you to find velocity, it means straight away you know it is instantaneous velocity at that particular point. Okay. So if you get a positive value when you differentiate and you substitute the value of t inside, you get positive, mean it moves to the right. And this is a vector. Velocity is the vector. Okay, so far this is quite things lah. And just to recap, speed is just a magnitude. It's a scalar form. You have scalar and vector. Scalar is a magnitude. Vector, you have scalar plus direction. And unit is important in this module. Always use units SI, meter, kilogram, second, and so on. We do not use imperial. Okay. Now velocity. Okay, so if yeah, this is just tell you that average speed is not velocity. Average speed is a scalar where how you find average speed, you take the total distance divided by change of time. Average velocity is what? This is start to confuse already. Average velocity, what you take? You take the last position minus the initial position divided by time. In this module, you're always interested in last position and the original position. Okay, so don't confuse with total distance. It doesn't. We are not interested on total distance you travel in dynamics. We want to know the position at the point of interest and the origin. Okay, so the rest is just a proof of equation saying that actually these two are different equations. Now, what does it mean? If you use this example, right? If you use this example, let's say the P, the P original position is the P. However, second position of the blue dot move to the left. It become P comma. And the positive direction S is to the right. So if you calculate average speed, you need to calculate the total distance traveled by P and then go back to the P comma. Okay. However, when you calculate the average velocity, it is not positive anymore. Why? Because the final position of that object is on the right, left-hand side of the origin position. That's why when you calculate the average velocity, you need to be careful on the position. Positive, negative tell you something. If you get your negative, if you calculate negative divided by positive value, you get negative average velocity. It means the velocity already moved to the left. This is a bit different from statics. We start to deal with direction. Again, in dynamic, we're more interested in final position to the origin position. We doesn't care in the process how it goes. Right? Okay, now acceleration. If you are good in differentiation, how you get acceleration? You differentiate velocity, right? So this one become double d double s d power 2s divided by ds squared. Means you differentiate 2 times. Okay, I go slow. I go slow. Okay. Now, if the question asks you about velocity, your diagram should show distance s and time on your diagram. If the question asks you about velocity, we want to see your diagram deal with the correct parameter, which is s and position. You need to tell me where is the positive, then you draw out the location of the particles or the dot. We're dealing with whole body. Now we see as a one dot. Okay, now acceleration, your diagram start to change s into vector v, velocity. Same notation. Original we use v or can vo. Second velocity we use v comma or v comma comma or v sub 2, v sub 3, and so on. And we start to give arrow already. Okay, now just now is position or displacement is only the position on the x-axis or y-axis. Now we go into velocity. We start to change the labeling for your object. Become v velocity. Also, as you know, to find the acceleration, the two position, you know that the object accelerate to the right. So you need to predict the acceleration, whether to the left or right. So on your diagram, if you draw to the right, you predict it to the right, you draw on the diagram, and then you assume the value of A is positive because you are assuming acceleration is to the right. And then you calculate, you get positive means what you guess is correct. You calculate, negative A means the direction flip. This is what you learn in statics. So here is more on the motion. So average acceleration is delta V, delta T, but instantaneous acceleration, we have the limitation like just now, it becomes dv dt. Yeah. Now just to summarize up to now, for the test 1 question or test 1 answer, you don't need to write delta anymore. Straight away give me A equal to dv dt, V equal to ds dt. Okay. So you see chapter 1 question, straight away you write the equation already. Definition of V, 1 mark. Definition of acceleration, 1 mark. Just write the equation. You write V equal to ds dt, 1 mark. You write A equal to dv dt. Without substitution, you get 1 mark. And then the diagram also, with the correct direction, I need to show the arrow and also positive sign. Where is the positive sign? With that, here maybe 1 mark or 2 marks. So without solving substitution, you only have 3 to 4 marks here already. Actually quite easy to score in this module, as long as you know the steps. The step is fixed already. You always do like these steps. First step, draw something and you identify, okay, this is chapter 1 question. Second, you write the equation for that chapter. So this chapter 1, V equal to ds dt, A equal to dv dt. So if you get positive value, it means it moves to the right. Start from this module, you need to tell me direction. Don't calculate, stop there. You need to draw arrow left or right, up, down. Okay, so if you derive from the previous one, V equal to ds dt, so you can write acceleration actually is double differentiation of your displacement. Meaning you take the V to the right, means you differentiate this equation. You can see, so means you substitute the V, you put the V to the right, you put this equation here, means you differentiate this equation again. You have double dt. Yeah. So you have 3 equations already. One is V equals to ds dt, A equal to dv dt, and also A equal to ds square dt square. You have 3 equations. Because sometimes the question do not give you direct V. It gives you S equation. You differentiate double time, means double the displacement, you get acceleration. Yeah. Okay, so this is the third part, the question section C. If you get the velocity as a constant value, if you say constant value means what? V, comma, the second velocity, and the original velocity is a constant, it doesn't change. Means it start with 10 meter per second and then end with 10 meter per second. Your acceleration is 0. It means what? Sometimes the question will be tricky. It just give you, it just mentioned, this object have 0 acceleration. It means velocity is constant. It becomes static question. It may be tricky. This is a very tricky terms. Sometimes question we do not tell you the value of velocity. We use acceleration to capture you. Means to trick you. The question will mention the object acceleration is 0. It means the velocity is same. Yeah. Okay. The next one. So these are the recall the three. Okay. Now a mathematical question. How to relate time differential dt between velocity and acceleration? These two equations, velocity and acceleration, you have the same dt, right? V equal to ds dt and a equal to dv dt. If we take the t as our command, means we freeze the time, we can determine v and a. We try to find one simpler equation to, once you find velocity, you can find acceleration, or once you find acceleration, you can find velocity. This is the question that what it tried to mean. Okay, so what you do, how you relate the velocity and acceleration in the time form, you rewrite the equation dt equal to ds dv, and also dt equal to dv dA. We start to derive equation already. We start to go into projectile equation. Yeah. Now, once you rewrite the equation in dt, you can form the one linear equation, right? You can write ds over v equal to dv dA. And then you integrate to remove the d term. Yeah, the step will be integration later. But I want you to see the next move. Okay, the objective of this one, why we rewrite the dt at on the left, because we want to find velocity and acceleration at the same time. Meaning, if you already know one of it, you can find another one. If you know the time, you can know another parameter. Okay. Okay, you rewrite in this form, ds over v equal to dv dA. But again, we don't write fraction form. We write linear form. So what you write? A to the left, v to the right. So can you see integration question already, equation? So once you have this one, you know automatic, you need to add the curly integration sign already. It's automatic one. This is what you learn in mathematics. So once you have this one, we don't write fraction form, we rewrite in the linear form. And you see d something equal to d something. What you do is you can add in integration. Okay. So so just now back to the acceleration. Acceleration equal to dv dt. We don't write fraction form. We rewrite in the linear form, where it is dv equal to a dt. And you integrate dv, what you get? You integrate something, what you get? You get accumulation of the magnitude. Same with this one. A, you accumulate with t. And then you check the dimension on the left and right. What is the dimension of unit for velocity? Meter per second. And if you take acceleration multiply time, you get meter per second. So two side balance. Yeah. So from here, you know that if you want to find velocity, you take acceleration multiply accumulation of time. If you want to find velocity, you take acceleration multiply time and you get velocity, and so on. Okay. So you add in the velocity, the touching or the curly. One careless mistakes, I want to point out. If you have integration sign, you need to follow the d magnitude or d parameter. If on this side is dv, you are integrating the velocity and not acceleration or time. Some of you might confuse when you add in the curly sign. So always follow what you differentiate or what you integrate. In this case, on the right hand side, dt, you integrate time and not acceleration. This will be the careless mistakes usually I see in the answer. You might confuse with what you integrate. So this you need to be sure. So This one with constant acceleration AC. Yeah? Constant means you have one fixed value. Yeah? So if you integrate, if you integrate this one, I skipped the derivation steps already. This one. If you integrate, what you get? V minus V0. Right? V minus VO, we write as V minus VO. Can you see it? You can see, right? Let me draw something. I'll write something. Okay, here, this one will become V minus VO, right? This one, A constant, pull out. So integrate this one is what? T minus 0. You rearrange, you get this equation. You pull the minus VO to the right, you get VO here, become positive sign. And we always like positive equation. Yeah, okay. Third, for those already from poly, you might be very easy for you, right? So I think the fourth equation for today is velocity equal to VO plus ACT. Start from chapter 2, you need to like automatic know what is the equation for this one. This is the projectile equation. Motion equation, we call it motion equation. This is rectilinear. Rectilinear motion equation by using velocity and acceleration and time, these three parameters. Okay, we're using the same approach, same approach. Using the same approach. Now, if you understand this one, we go for another equation. Now, just now is A, V, and T. You know that your acceleration, you can write in S and T, right? Now we derive the equation. If you're given V equal to S, differentiate with time. Can you arrive at one linear equation integration just now? If you understand the previous one, the same approach. Now you start with V equal to ds dt and you move V dt on the left, S on the right, or ds on the left, dv dt on the right, become a linear form, and then you put in the curly sign, you arrive at one linear equation also. Yeah, you rewrite as a linear equation, ds equal to v dv, right? And we put the position in the function of time. So you have curly sign there. From origin to the last one. Okay, integration, you have lower limit, upper limit. Lower means origin, upper is the final position or final time. Integration doesn't care what is the motion in between. It doesn't care how you move, right? So at the end, you arrive at V equal to, this is V equal to VO okay. Maybe I move a bit fast. Okay. 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 Maybe. Okay, this is the previous one. This is the previous one. Okay. So if you do the same, okay, how you arrive this one? Actually, you rewrite the equation. This one. This one you get SO minus S. This side you get V. Sorry. SO. Sorry, S minus SO. And then you pull the T to the left, you get velocity. Right? Okay. You do the same. You substitute the V equation just now. Right? The V equation just now, V equal to VO plus AC into this equation. Why we put in this equation? Why? Because if you only use V, you do not see the motion of the object. You put V is a constant value, or it doesn't mean anything if you integrate, because there's no T there. There's no T in this yellow color V here. You cannot see the time component inside the yellow color V there. It was hidden inside. So in dynamic, you need to find out. You cannot stop here. In careless mistakes, most of careless mistake, you assume is one vector like this. So dynamic, you need to check back what you derived previously. This is the careless mistakes part. You always, if you continue from here, you get VT. VT doesn't tell you the exact, you miss some of the component. Yeah? Okay. So, understand? It's not okay? So why, what is the difference between these two if you do not substitute? So if I plot graph, this one, you'll get a linear graph like this. This one, if you substitute inside, you might get something like this or like this. Because of VO. It might like this, like this, like this. The inference of original velocity. If you do not substitute, you don't see it. Yeah. Okay. Boleh ya? Okay. So one more minute. I think we stop for the day. If you derive, you arrive at the three equation, the third equation, which is S equal to SO plus VT plus half ACT squared. Yeah. Okay, we have derived the projectile equation already, that you learned in your statics. Right? Can you remember? Okay, so I just recap. Let's see if my next slide got shown or not. Okay, this one, if you have question later, you can come and ask me how you arrived this one if you don't understand. Okay, so another equation. This one you go home and read. This is from here. This is from here. Okay, I think we stop at this slide now. We stop at this here. Okay. Okay, I pass the class to Datuk Dali. Attendance somewhere inside this one. You go and find out where is it? Huh?